So, welcome, guys. I hope you are doing good, and welcome to my channel, Logic Bytes by AK. So, I'm sure that you are going to learn something new from this video. Please make sure that you don't miss any part in this video. So, and I noticed that something that my video lectures are a kind of slow in while explaining the topics. So, I prefer you to change the video speed from 1.2 to 1.5 in the range in between that, so that it gets in a straight way. So let's check our daily challenge question on LeetCode. So the given question is a number complement, which is the complement of an integer. The integer you get when you flip all zeros to ones and all ones to zeros in its binary representation. For example, the integer 5 is a binary representation in 101 in binary, and its complement is 010, which is integer 2. So here the 1 is changed to 0, the 0 changed to 1, and again 1 changed to 0. Means of flipping a binary representation of a number and calculating the resultant binary number to an integer number. So given an integer num, return its complement, right? So for 5, the binary representation is 101, and after flipping each bit, it gives 010, which is binary representation for integer 2. And let's go with example number 1. So for 1, the binary representation is 1. After flipping 1 to 0, the resultant binary representation is 0, and 0 integer is also 0. So yeah, the nums range is from 2 power 31. So okay, so let's go with the painter to get more explanation on this. So let's take a number, let us say 11. So what is the binary representation for 11? I mean, how do we find the binary representation for a number n? We do one process, right? So let us take, we divide with we divide 11 with 2 uh, 5 times, so get a remainder of 1. And after that we have to again divide 5 with 2. It goes 2 times and we get a remainder 1. And these 2 also should be divided by 2, which divisibles by 1 time, and it gives us remainder 0, right? So the binary representation is, wait a minute. So yeah, after what we got 1, right? So we again divisible, I mean we divide 1 with again 2, it goes 0 times and leaves us remainder 1. And for binary representation, which elements we consider reminders, right? Reminders in reverse order. So for 11, the binary representation would be, we have to go bottom to up, right? So it would be 1, 0, 1, 1. What does it mean? So the first one represent value 1, second one represent value 2, plus third value represent 4, but we didn't include it 4, but the fourth value represents 8, and we included 8, so we add 8. So in total we got 11, right? So that's how we calculate a binary form for an integer. So this is the binary representation for 11. After finding binary representation, Let us say we store binary representation in string format like 1011 in a string. So now what we have to do, we have to iterate over a string, right? So we check a character by character. If it is one, we don't have to do anything, right? So let us say we have our answer variable, right? Uh, Wait a minute. So let me remove this. So let us say we have x as an our answer. I mean complement number. So what we have to do? If it is so we have to come from end of the string to starting point, right? Because we don't know how many digits are there from I mean at the back. So if we come from this, we can if it is one, we multiply and we make it zero, right? So our result array we and it is one, so we make it as sorry we make it as zero, and this is also one, we make it as zero, and this is 0, so we flip into 1, and this is 1, so we make it as 0. Now after changing these, what is the resultant binary string? It is 0100, right? So when we converted this binary representation into integer, what will be the result of x? So here it is 1, 2, 4, 8, right? So we considered only 4. So let us say we got x equal to 4. So for number 11, the complement is 4. So let's check in that platform. Let's verify just. Yes, guys. I'm not writing any code without suppressing errors. We just simply return 0. Now we just find what is the complement value for 11. We make sure that it is 4. If it is 4, we have done correctly. So let's check. It is 4. So the approach was correct. So let me define an finite approach. Yeah. So what we are doing here, firstly, we need to find a, we need to find the binary representation, and we have to find a number from binary representation, right? So let us say we need a function which takes we need a function which converts number to binary, right? bin, and which takes input as integer, takes integer and return string, right? And we need another function which takes a string and returns integer, right? So binary to integer, that's int, sorry, which takes a string as input and it returns integer value. So yeah, so for converting a number into binary, we know the approach, right? So what we will do initially, we need a number, right? So we take n and we need a string to, to store the reminders, right? These reminders, right? We need a string to append these reminders to the string. So firstly, let us say, yeah, we have this, and here n is 11, right? For first, n is 11. So after that, what is the n value? It is updated to 5, right? So firstly, what we have to do, we have to find the remainder. Let's say remainder equal to num percentage 2, and we got that remainder. We append that remainder to the string after type conversion, right? And the n value is updated, right? Up, n value is updated to its, I mean, what do we call this? A divisor or something. So it will be updated to 11 by 2, which is n by 2, right? So n always be updated with n by 2. And we continue this process up to n becomes 0. So while n not equal to 0, we continue this process, and if it is 0, we stop. So at the end of this while loop, what we get a string of binary representation, and this binary representation is stored in this approach, right? So firstly we calculate this binary and we add it to the string, and after we find this we add it to the string. It means we are coming from top to bottom, but the correct binary representation is bottom to top, right? Yeah, that's the correct approach. So what we will do, we we reverse the string. Reverse the string equal to, let's say if we use any predefined reverse of s, right? So after getting a reverse string, what we have to do? We have to change its ones and zeros, right? So if the character of, let's say our binary string is 1011, we got this, right? So we iterate, let's say, without using this function binary to integer. I mean, in a string we cannot change the index values, right? So string is immutable. Let's say we just iterate from end of the array to the starting. So if it is 1, we don't have to do anything. So we iterate only on zeros, right? So if it is 0, we add 8 to the our answer, right? So here x is the answer. Initially it is 0. So when we are iterating from this way, when we get the 0, we add x to the 0 bit position power 2, right? So the 0 position from at end of the array is 3, and we find 2 power 3, and we add 8 to the our answer, right? So that is the approach. So yeah. So here also it's the same, right? So in zeros, if we have 1, what we will do? We find 2 power 1. Sorry, sorry. It is not 8, right? It is 4. We find the second, I mean the 0th position minus 1, right? Which is 2 power 4. I mean 2 power 2, which is 4, right? So what we will do? Yeah, in case of 1, the index value of 1 from end is 0, right? So 2 power 0 is 1 and we don't add that one right to our x. So because it becomes 0. Becomes 0 means we have to add 0 to x when it is 1. So when it is 0 in the string, we add its 2 power position minus 1. So let's code it. So guys, and we need a integer to a binary string conversion right? Method, right? So public string into bin, I mean binary. It takes integer now. And we need a string x initially to be nothing. So we iterate. We continue this process by n greater than or equal to 0. Let's say now we need a reminder which gets by n percentage 2, and we add that reminder x equal to x plus string dot value of reminder, and we decrement n by 2. So last we return x. And the x is in which position from it gives us from starting to ending, right? I mean, first, firstly, we take uh, 1, 1, 0, 1. So our result will be, our string will be in this format, right? So what we have to do, instead of reversing it, we can start from here, right? I mean to say, let's take this approach. Yeah. So at index 1, what we multiply our 1, 2, 4, 8, right? These are the powers of 2. So what we can do, so the index is 0, 1, 2, 3. So if you observe guys, so whenever we have to add, so whenever we get 0, what we should do, we have to find the power of its, I mean 2 power 8 index value, right? So we got here x equal to 0 at index 2, and for our answer what we will do, we find 2 power index these two and we add 4 to the x. So yeah, we have to just return x, and we get string binary equal to from into to bin with num, right? After getting binary, what we have to do, and we need our result, right? Result equal to 0, and we iterate over a string. Let us say for int I equal to 0, I less than binary dot n I plus plus. So if s dot character at I equal to 0, what we have to do, we have to find 2 power I, right? So how do we find 2 power I? So for to calculate 2 power I, let's say we need a function which returns int value, power of 2, which takes exponents value exp, and what we have to do, we need a power value k which initially 1. So we iterate while exp greater than 0, we multiply, I mean it's p equal to 2 into p and exp minus 1. So we return exp. So I hope this works. So for the first iteration we will get 2 and it will be reduced to 1, again it will be multiplied with 2 index first. So let's rs plus equal to power of exp, which is I, power of 2, right? And we return rs. Let's run it again. S is a binary, right? So now when yeah, it goes wrong. So so here it's not 0, right? It is character 0. So let's run it again. So it still goes wrong. So it goes wrong. Let me just print a binary string. Just convert it correctly. And binary string is good. For line it is 1101. Um, go with 0. So if it is x equal to 0, let's say we have to return p, right? We have to return p here. So, yeah, it works. So let's check is there any case. So if you observe guys, it's not the optimal solution, right? Because we are doing a lot of process. Firstly, we are converting it into string and we are iterating over string and again we are calling a power function, right? So it's not optimal solutions. So let me explain optimal solutions. So if you if you are familiar with bitwise operators, then get we can beat 100% of the. So let's say we need a result array. So what we will do, we will do this process while n equal to 0, right? So let's check what is the last bit position. How we check the last bit position? So if n percentage 2 equal to 0, it means then it is even number, the last bit would be 0, right? So if it is 0, what we have to do? Let's say we need a index I equal to 0 initially. So if the last bit was 0, we have to add our res and one representative of I. So which this left shift operator says that we have to shift number one, one bit I times, right? So initially, let's say we got 5, and for 5, n by 2 is not equal to 0, right? So whenever it is equal to 0, there we get to know that it is simply representation of 2 power I. And after that, we increment our I value by 1, and we have to decrease n by n by 2, right? Or we can say that n left shift one time, which is both of them, and we return res last. Let me run again and again. So here n is num, so we change the parameter. Yeah, it goes well. So that's the importance of bitwise operators, guys. So yeah, now you can see that it beats 100% of the users. So that's it, guys. That's it for today. And See you in the next lecture. So if you have any queries or any suggestions for me to improve my communication skills, you can comment down below. And I'm also doing a top 150 interview questions on LeetCode. I created a playlist on that, and I am also solving dynamic programming, which is a very important topic in DSA. So I started a playlist on that, and you can refer the problems in it. So thanks for watching, guys, and see you in the next lecture. Bye.